Welcome back. We're having a look at question 3. What a fabulous idea this is, the idea of the areas between curves. Now, in my particular tutorial, just as an aside, what I did was I said to students, let's find if you've got a sine wave and we go from 0 to 2 pi, and we integrate that from 0 to 2 pi, what happens? So let's do sine theta d theta, it doesn't matter, but let's do that. So the integral of sine, the differential of sine is cos. So the integral of cos is minus sine. The differential of sine is cos, so the integral of cos is sine. So the integral of sine is the other one. So it's minus cos theta between 0 and 2 pi by FTC. Now, our scaffolding will be based on 0 and 2 pi. So we'll have minus cos 2 pi and minus cos 0. Now, our exact values trig require us to understand that 0 and 2 pi are here, and the cos is asking for the length there, and we know that's 1. So cos 2 pi is 1, cos 0 is also 1, so we get minus 1 minus 1, which is minus 1 plus 1, which is what? Clearly the area of the sine wave is not 0. We have to do it twice, or separately and independently. And this little section here, these couple of questions, suffer from this particular problem. So if we have a look at y equals x squared minus 1, and it's giving us particular limits. So it's suggesting to us that if we integrate between here and here, that this won't be a problem. But like this problem here, like the sine wave problem, I believe we will run into trouble. So we need to have a think about our x squared minus 1, and it's just a shifted down happy face. Okay, it's just a shifted down happy face. And what we'll find is that if we find what the limits are, what the solutions of this thing are, by putting them to 0, undo, which is plus or minus the square root of 1, we will get minus 1 and 1. Our particular problem is asking us to do these areas. So when we're doing this, we need to give an account of the areas. We want the total area, not this kind of silliness where we get minus. Okay, so we need to do it piecemeal. That means we need to integrate the function from 0 to 1 as x squared minus 1, and then we need to integrate the function from 1 to 3. Okay, and let's have a look. We will have a look at what happens. All right, we'll do this one at the end just to show you. So this one here is going to be up and under, and where before there was no x, there is now, between 0 and 1. We'll plus it, if you like. And this one here will be the same. It'll be the same, which is that it'll be x3 on 3 minus x between 1 and 3 by FTC. We'll get 2 scaffolds then. Well, this one will have 0 on it. So because it's a polynomial, I'm going to discount that. But here we'll have 1 in here, and also we'll have 1 cubed over 3 minus 1, which will be 1/3 minus 1, which will be So we have a problem. All right, let's go on to this one. We're going to have our scaffolding. This time we're going to have a 3 in there, and this time we're going to have a 1 in there. So we're going to have 3 cubed over 3, take away 3. Here we're going to have that 1 cubed again over 3, take away 1. So we're going to end up with 3 3s are 9 3s are 27. 27 divided by 3 is 9. 9 minus 3 will give us 6. 1/3 minus 1 is minus 2/3, but it's minus 2/3. So it's plus 2/3. So it's 6 2/3. 6 2/3. Now, what's the truth here? What do we do? Well, this minus is a minus because it's underneath the x-axis. Okay, we said this. This is informational. That minus is simply telling us that it is below the x-axis. However, we want that 2/3. Okay, we want that 2/3. So 3 6 18, 20 on 3. 20 on 3. And to that we want to add the area total. It's going to be 20 on 3 above. However, we're going to add 2/3. So the total area will be the sum of both of them. Now, when you do Wolfram's between the area between the curve, this is what it does. If you just go ahead and do an integration, you'll just get a different answer. Okay? So let me just check that. And so we'll end up with, what are we looking at? 3. So we've got 22 on 3, which is 7 1/3 units squared. Both of those answers are correct. Now look what happens when we go and do this. Up and under. I mean, that's what your instincts would tell you, wouldn't it? Just go integrate. And this one here has got a 3 in it, so I won't even bother. 0, I mean. So I'll just discount that one. This one's getting a 3, so this would seem to make sense. 3 3s are 9 3s are 27. 27 divided by 3 is 9. 9 minus 3 is 6 units squared. So what's the answer? That is the difference between these two. Okay, this is wrong. Whoops. This is wrong. So we must take into account the nature of the problem. These were all fine because they were well defined. Okay, but as soon as the definition changes, we need to take that into account. Just like we did for the silly sign problem. How would we go about doing that? We would separate them and we would add them together. We would use absolute values if necessary. I could put that in absolute values, but I don't want to do that. I want you to use your common sense, please. All right, so for question 4, I'm going to run down to another page here and just put question 4 in here, because question 4, it's a similar thing, isn't it? X cubed. Y is equal to x cubed. And it's deciding for us between -2. Now, a cube looks like this. A cube's got a lovely swoop up. It's an S shape. Beautiful S shape. And it wants us to do it from -2 to 1. Now look at that. A large part of the area is negative. In other words, the area is not negative, the integral is negative. So when we come to do this integral, we really should be doing it in two parts. We really should be integrating from -2 to 0 x3. And we really should then be integrating 0 to 1 x3. And then deciding how we're going to add them. Okay, so let's do that. Up and under between -2 and 0. So we're doing it piecemeal. That's our approach. Same thing here, but this time we're doing it 0 to 1. So we're doing it piecemeal. We're doing it part by part. So our scaffolding here will be 4 and 4. We'll have -2 in there and 0 in there. Over here we'll have a similar scaffolding, which will have a 1 in it, and the other one will have a 0 in it. So we probably don't even need to worry about that second term. Okay, so this one here will go, and this is an even, so this is going to become positive. We're going to be left with 2 2s are 4, 4 2s are 8, 2 8s are 16. We're going to be left with -16 on 4, which is -4. What's the problem there? It's not -4 units squared. This one here is 1/4 units. That's okay. That's a little bit above. But what are we going to do here? So the area total is going to be equal to 4 plus 1/4, which is 4 1/4, which is 17 on 4 units squared. So we need to be very careful when we're doing these problems, how we're adding them. Because if we just go ahead and integrate, there'll be a predominantly negative value, but it'll be effectively short by that amount. So we need to be extremely careful when we're doing these. Alright, question 5 and 6 I did earlier, so we're just going to run through them. Question 5 is between two curves. Now, the rule basically is that you take the greater curve. The greater curve, okay, f of x, and this one here we'll call g of x. So over this interval, f of x is greater than g of x. So this is effectively f of x minus g of x, and we've seen that in the workshop notes, okay? So they've been set up deliberately. We had to work out what the parts were, so y equals y meant that x squared, but you can't just use this x squared minus x, okay? I've taken the larger of the two over the interval, this one, and subtracted from it the smaller of the two over the interval, which is the one underneath. If you don't do that, you'll get a negative value. Now, it's not quite the same problem as I spoke about earlier, in that there's a difference. You will get the same value, it's just that it'll have a minus on it. So you need to just think those through. They're just problems of thinking those through. So up and under by FTC, doing the scaffolding for the square and the cube, that's got a 0, so we can dismiss it. But then you've got these annoying numbers. Adding fractions never goes away. So 1/6 units squared, and we get 1/6 units squared there. Okay, so it's very important that you follow along in making sure that you're making choices. So there's our fundamental idea. The larger of the two areas, subtract the smaller of the two areas, and the result will be a positive. Okay, if you do it the wrong way round, you'll get a negative. It'll still be the same number, but it'll be a negative. Okay, so just be careful. Don't be caught just integrating willy-nilly. Now look, I've done the same thing here. The upper or greater than function, 50 minus x squared. So I've called that one f of x. Subtract g of x. G of x is the one underneath. So that's the way I've set them up. Now I couldn't do that here to find out what the limits were. I had to go through and say 50, put it over 2x squared plus or minus 5, so they became our limits of integration because that's the common point, y equals y. And then I had to put those on the limits, but then look, common sense prevails. Okay, so if we formed it up as function minus a function, and algebraically it's okay to say minus x squared is minus 2x squared, and then we can start integrating. Okay, so please just be mindful and careful when you're doing areas because it's a bit of a trick. Okay, you need to be very thoughtful about it, particularly when there's areas above and below the x and x-axis as there were in those two examples that we saw. Okay, that's enough from me for the time being, so I will see you next week. Thank you.